Let's start this session. Hi, everyone. Thank you for joining DataCon LA 2021. Welcome to the Data Engineering track. My name is Ruben Barrios, your host, and our co-host today is Joanna Perdomo. We will be moderating the chat and QA for you during this session. Today, we have our guest, Daniel Farrell, and he will be talking about using Apache Cassandra as your document database. Daniel is a five-time published author. Daniel Farrell has been designing and delivering worldwide critical business applications using relational, object relational, and post-relational predictive and graph analytics. Without any further, I will hand this over to the speaker. Thanks for being here, Daniel.
Thank you, Ruben. Good afternoon, everyone. So the title is Using Apache Cassandra as Your Document Database. The what, why, and how of that from an application developer. And that might be a slightly disrupting title because most persons would not assume that you can use Apache Cassandra as a document database. NoSQL databases, there are four primary types: key value, wide column, graph, document. Cassandra is not normally associated with being a document data store. Why do you care? Perhaps the most important of the five questions we can answer: who, what, when, where, why. Why would this be something you were interested in? Well, if you're a web developer, we're going to have a slide in about 3 or 5 slides, which is kind of the why you want to use a document database. You will be writing less application code. You'll be delivering your applications more quickly. Certainly if you're doing browser apps or mobile apps. And if you're using a SQL database or a NoSQL database other than that of type document, they force you to remodel your JSON, the de facto standard for data format on a web or mobile device. They expect you to reformat your data into things other than JSON, which is unfortunate. Shredding your document into rows and columns, which is just more code that you have to write, more things that can break. We call it, the industry calls it, an impedance mismatch, to have to move from JSON to rows and columns back and forth. There's software to help you do that, but wouldn't it be nice if you didn't have to do that at all? And then lastly, we'll talk about not only being able to use a document data store, leaving your data in JSON, but what that means also for performance and indexing. So let's not do that shredding of JSON into rows and columns. Let's just stay in JSON, and that is the value, one of the values of a document data store. The what? So Apache Cassandra is an Apache top-level project, so it's got an ASL2 license. And of all the databases you could choose, open source Apache Cassandra, how does Cassandra, when would you choose to use Cassandra? Out of 100 different applications, maybe some are better suited for a given database, a given cache, when would you choose to use Apache Cassandra? So Cassandra differentiates itself in that it is truly linear scale. Lots of database platforms do scale very well. Most claim to scale linearly. Cassandra does scale linearly. Some do, some don't. Another reason you would choose to use Cassandra is it is always on. And if you know anything about the CAP theorem, it says that the letter CAP, that a database generally can be 2 of those 3 letters, not all 3. One of those letters is P, network partition fault tolerant. And we'll have a slide on that later. But basically, if you need that feature, network partition fault tolerant, you probably are going to use Apache Cassandra. Along with that network partition fault tolerance is also localized reads and writes. So if you live in LA, Ruben lives in LA, but he's traveling to EMEA this weekend, his data will still be writable locally. And what that means to we as a business is that he'll be writing locally, even though normally 100 days out of 100, he's normally in LA. Because his data is going to be local in EMEA or Asia Pac or wherever he is, the write times are still going to be 0 to 8 milliseconds. So stupidly fast, and it produces better performance in the application. Pages load faster, etc. So that's Cassandra, but how are we getting a document capability, a document database capability in Cassandra? And the answer to that is also open source, also Apache software license version 2, and that's Stargate.io, brought to you by the same people predominantly behind Cassandra. Stargate.io and Cassandra.io. Cassandra is the Kubernetes distribution of Apache Cassandra. And embedded within Cassandra comes Stargate. We'll talk about what this means. We have slides on this. Effectively, Stargate gives you a stateless middle tier, automatically generated and maintained, and that will give you the document API, your document database capability, and also, again, automatically generated and maintained REST, GraphQL, and others. Cassandra is the Kubernetes distribution of Cassandra. All three of these words in bold, Stargate, Cassandra, Cassandra, are all Apache Software License v2. So we mentioned network partition fault tolerance. What does that mean? What that means is there are multiple writable copies of any single piece of data. So I can have a copy of Ruben's data in LA, I can have a copy of Ruben's data in Norway, and who cares? Same piece of data writable. We care because if the network fails, nearly every other database on the planet has one side that's down. You can have 2 or more copies of data with pretty much every database, but when the network fails between those 2 copies, every other database other than Apache Cassandra, one side of that network is down. And if you're a global company, whatever it is you do for a living, that means that one side is not writing, it's not reading. And with Apache Cassandra, say, for example, one side of the network, you're scanning packages and loading planes, and on the other side, you're preparing for the plane to arrive and you're scheduling trucks and saying where these packages are going to go. Unless you have a network partition fault tolerant database, that would be no bueno. It's not going to work unless you have that network partition fault tolerance. So the network can break, both sides are still writable, same piece of data. And when the network is restored, Cassandra automatically cleans that up. And the best surviving piece of data based on timestamps is propagated throughout the entire network, and that's built into the platform. Multiple writable copies of any single piece of data. And you could have 2 copies, 3, 4, 5, 20, whatever you think you need. And that also means then that we said if someone's traveling all day and all night, they're in LA County, so it's super fast, the network speeds, latency, it's super quick, but when they do travel or go elsewhere, again, it's a localized read, it's a localized write. So the application is still snappy, it still loads faster, and that produces better performance in the application, less abandonment of shopping carts, etc. Multiple writable copies of the same piece of data at one time. So that's Apache Cassandra, linear scale, always on, network partition, fault tolerant. So what's this thing Stargate? Stargate is also open source, also ASL v2, and it comes in Cassandra. If you just load Cassandra, and that is a Kubernetes distribution, it will give you Cassandra, it'll give you everything we're about to discuss in Stargate, puts them all in containers, keeps them running, you can scale them up, you can scale them down. But what is Stargate? Stargate is basically a stateless middle tier. And from this graphic, we could see a terminal and we see a mobile device. Each of those can speak CQL, which is the Cassandra version of SQL, but perhaps faster and better for us as application developers, I can speak GraphQL, automatically generated and maintained with Cassandra and the Stargate.io subcomponent, REST, other communication protocols, and those are automatically hosted, automatically generated, automatically maintained. That's just less code that I have to write. I don't have to stand any of that up. It comes free of charge. So now I can just write my application. And the security is integrated, everything, schema discovery, if you're used to using GraphQL, it's automatically generated and maintained. And last sentence on the page, why do I care? Because it's less code I have to write as an application developer. Pick your numbers. At 2% of my application, 5%, 10, 20% of my application, I didn't have to write it. I can just write my business routines and deploy an application. The rest is generated and such for me. So one of the things we get in Stargate is a document API. And what is that? So on this slide, we have sort of in the middle or the top line, the standard formula we expect with SQL. SQL is still the de facto standard for most database applications on the planet. SQL models its data in rows and columns, two-dimensional, generally a fixed set of columns, and no matter where your data is coming from, you have to meet the expectations of SQL. So on the very right here, I was working in my application, be it web or phone, and I have JSON because that's what web applications and mobile applications talk, what they understand. JSON. So I have Mary Jones, her cell. I have an embedded record for location. I have an array of elements under something called apps, an array of the cars she owns, and it's formatted in JSON. And if I was writing to a non-document database, probably a SQL database, I have to go through a process where I shred that JSON into rows and documents. And here we have an example. There's probably a table for person. There's a table for profession. There's a table for the applications they have. I have to do joins. There's a fourth table for the automobiles they own. So I have to shred this single record that my application understands into 4 tables and 7 entities in order to stuff it in the SQL. And if I want to extract it back out of SQL, I got to do joins and again, reassemble it and put it back in the JSON so my application understands that. And the point of this slide is in a document database, you don't have to do any of that. Document databases natively understand JSON, and with the Stargate IO project to Cassandra, I can just speak JSON. I don't have to shred. Things are easier, faster, bigger, better, stronger. And this would be a feature of all document databases of which we can get using this software. So an additional consideration here, when you do have to shred your JSON document into 4 tables and multiple rows and multiple columns when you're not using a document database, consider too the indexing. So first of all, what is an index? Our table proper is a 2-dimensional rows and columns representation of data. An index is a vertical slice of that table, generally all rows and a subset of columns. And so that the index can be a more performant way to retrieve rows, generally the index structure, all rows, subset of columns, is pre-sorted, probably has a structure in front of it like a B tree or a hash, so that when you say, hey, let's find that Mary record, it knows how to quickly search through and find the Mary record quickly. But each of these indexes has to be automatically maintained by the database server. And have you considered an index is all rows and a subset of columns? If you have a table with 10 indexes, then inserting 1 row into that table is like having to do 11 inserts. Because the index is all rows, so the row has to be recorded there also, and a subset of columns. Rather than doing the equivalent of 1 insert, if I have 10 indexes, I have to do 10 inserts or 11 inserts. And does that scale as well? No, it doesn't. And that's our issue. If you have 120 index columns, it's like you have to do 120 inserts. And so couldn't there be a more optimal way, especially when using a document database, to get around this? And there is. So first of all, how do you invoke the document API? So a leading thought of late is rather than having your application developer know so many different domains, wouldn't you just prefer if your application developer was working on, say, Node.js and React? Let's just know Node. Let's just be really good at that. Or if you're working on, pick another one, Python with Flask. Wouldn't it be nice if you just knew how to do that? Or one of the mobile platform, C# or other, just know that. Why do I also have to learn SQL and I got to learn this and this and this and this? And in the case of Cassandra, years and years ago, you would have to learn the Cassandra version of SQL called CQLC for Cassandra. And so the thought of late for higher productivity is, let's not do that. Let's just run REST calls or similar. And so here we have an example using REST or using curl, how to invoke the document API. So the first box is your authentication. So you hit the server and you're like, I'm Ruben, here's my password, and they give you a token back. And then from the command line, just for prototyping, or using a GUI or whatever, you can run a curl command and then you pass it your data, which is your unshredded, natural JSON formatted data. And this will hit the document API based on your URL. So there's no shredding, and the response you get, in this case, as an insert, it's a post, you would get your document ID in response, but no shredding, no what have you. And notice nowhere here did I have to learn 4 SQL tables with joins and SQL inserts and what are the rules for that. I just post effectively my data, which is the JSON document. So a little bit more detail on the last slide, the document API. So document databases tend to call their tables collections. You can still call it a table, we know what you're talking about, but they tend to call them collections. And instead of rows, they tend to call them documents, or the fields, instead of columns, we call them fields. The table can be created dynamically just because you wrote to it. And new columns are created dynamically just because you inserted or upserted. And the column types can be overloaded. So half the data can be int, half can be char. We do actually recently support document validation, just like SQL check constraints. The collection based on where and how you run this could be 64 levels deep or 54 levels deep, which is pretty darn deep. You can have all sorts of complex types of data, scalars, dictionaries, arrays of dictionaries. If we go back to that last page, here I have a couple scalars, first name, last name, but I have embedded records, I have embedded arrays of records. There's really no limitation on how complex the JSON could be, minus the fact that you do, based on how you install this, run to a certain number of levels deep, and then they're like, okay, let's stop there. That's getting too complex. And you can have text, Boolean, etc. But what about that indexing thing that we discussed? So what we do under the covers for optimization is we store all of the identifiers. So first name, or let's make it more complex. They had autos, .make, .year, .this, So those are all stored as a retrievable key, but then the actual value for the attribute or the field is stored in just one of a small number of columns, be it a Boolean, a double, an int, a text. And this is how, instead of having a standard SQL table with 120 index columns, so I have to do all these maintenance routines or whatever, because of how we store this document, we only need to have these 4 indexes in addition to the primary key in order to index whatever number of columns you might have in that document. Better to have 4 indexes than 120 indexes. And then if you're like me, you'd probably want to see a sample data. So this is the Mary Jones record that we were inserting earlier. And we see that all the Booleans are stored in one column. There were no Booleans. All the doubles for lat long are stored in one column. All of her scalars are stored in the text value. And not only does this improve performance because we have a smaller number of indexes, but there's also a number of use cases that are much better served. Think about tagging a record for ease of search. And so I want to find Mary Jones just based on the fact she runs a Bentley or she runs DocFinder 2.5.7 or lives on Long Island. I really, in an advanced use case that's supported by this schema, don't even need to know how Mary, as a scalar value, her first name, was stored. I can just find it in this list because of the commonality of the column called text value. We did an insert. Here's what the query would look like. It's also, well, we ran it as curl. You would run it in your application program as whatever. And as a query, it's a get versus a post. And I just wanted to show this. So here we can look for, it's kind of like an in query in SQL. So here I put a star for any element of the array storing cars. If I wanted to look just their primary car, the first car, I could put a 0 or 1 here. But this is how I query anyone who drives, in this case, a Bentley, and that's a supported syntax. Here I show the first element. Indexes are starting at 0 and then 1, 2, 3, 4. And so the queries are just as powerful as the insert not having to shred the data. A couple takeaways. So as we said, hundreds and hundreds of fields, just 4 indexes rather than having hundreds of indexes. Full and complex JSON is supported. We talked a little bit about I could find records similar to search tags without having to create that manually myself. I can just look natively at the floats and the double columns as search tags. This document, the Mary with all her cars and all her applications, is stored as one contiguous block on disk, one document on disk. And so the retrieval of that, it's a single physical I/O. And because this is sitting on Cassandra, it's network partition fault tolerant, linear scale, localized writes, all the things you get from Cassandra. Don't have to shred your JSON data into rows and columns. And lastly, all of these REST service endpoints, GraphQL, document API, etc., are automatically generated and maintained for you. If you're like me, when I first encountered this software, I wanted to load it on my laptop. So one more time from the top, if you want to run this on your laptop, you can run just Stargate.io against Cassandra or other platforms, actually, and you'll get that document API. Cassandra is sort of a layer above, and that's a containerized distribution of Cassandra and Stargate. And if you haven't gotten to Kubernetes yet or containerized applications, you probably will soon. It's quickly becoming the de facto deployment platform on planet Earth. And what you get by using Cassandra is just 1 or 2 commands. You have to install Helm. You need a Docker runtime probably. But Cassandra will deploy all of this for you. Cassandra, multiple nodes, data replication if you wish, the Stargate, the document API, and keep all of it running just because you used a Kubernetes distribution of this software. That's the Cassandra.io. Ruben, that's our content proper. Have we generated any questions in the chat room?
Yes, the first question is, I appreciate the clear layout of what Apache Cassandra is and its strengths. Are there any common misconceptions about the capabilities of Cassandra that folks have?
Yes. So Cassandra was created it was inspired by 2 seminal industry white papers. And effectively, Cassandra set out to solve a problem. And as such, there are things that Cassandra will do for you, and there are things Cassandra doesn't want to do for you. It wants to linearly scale your data forever. And so operations that do not linear scale, Cassandra doesn't want to serve those. It wants to say, look, if this is important to you, you need to model your data in such a way that it will scale linearly. So one of the common misperceptions against Cassandra is it's hard to use, and largely it might be a misunderstanding. Cassandra does what it does, and it doesn't do what it doesn't want to do, because he's promising you, she or whatever, is promising you that it's going to scale linearly. And if it's an operation that doesn't do that, then you need to model your data differently, and until you get that whole mindset, it's not that Cassandra is poorly written and doesn't want to do, say, a leading wildcard on a string. Just Cassandra knows that doesn't scale. So if you need to look at the last 3 characters of a string and get linear scale retrieval, great, model your data that way. Don't ask Cassandra to do things that are poor in performance. So misconceptions against Cassandra. It knows what it wants to be. Linear scale, always on, network partition fault tolerance. And often if you're struggling getting Cassandra to do something, it's because it would violate those promises that Cassandra makes to you. Did that answer your question?
Okay, thank you. The other question is, if someone wants to make the switch from a different database, is switching over the Apache Cassandra, are there any common challenges someone might expect to encounter?
Yes. So without stating it explicitly in the first question, so it could be said that, say SQL. SQL, most SQL databases are by default, you could think of SQL databases as general purpose databases. They can serve all sorts of ad hoc queries they can do. And one of my favorite examples is you call the power company, the electric company, and you say, hey, I want to talk about my account. And they say, great, what's your account number? And you're like, I don't know. Why would I know that? That's your number. That's not my number. I know my phone. I know my kids' names. I know my street address, but I live in an apartment building, so my street address is kind of complicated. So a general use database can find you 5 or 6 different ways. And you might even say, look, I didn't set this up. My wife set this account up. She used her maiden name, maybe. I don't know what my account number is. So general use databases have a wider array of services that they apply. Remember how Cassandra was created. Cassandra said, before I do anything else, I will always be on. I will linearly scale. Cassandra would rather, if Cassandra cannot linearly scale, he's going to be upset. I keep saying he, I apologize. So when you migrate, why would you migrate from any other platform to Cassandra? Because you need the things Cassandra provides. Linear scale, your business is getting ready to explode in growth, your volume's going way up. You need that 0 to 8 millisecond response time for web or mobile apps, no matter where the user is on planet Earth. You are probably global. It's really important for you to always be on. That's why you might migrate. And then when you get to Cassandra, there's things that Cassandra will not do that a basic relational database will do, because it's not a scaling operation. And so again, we implied in the first question, Cassandra is going to ask you to model your data in such a way that it will scale. So the data modeling is much more critical in Cassandra, but generally, with that constraint, knowing that you have to model your data in support of your queries, Cassandra will then service your application. Next question.
Okay. We have another question that says, are there resources that you recommend to get started with Cassandra?
So most of the NoSQL database vendors will have an academy or a university, free classes online. And a colleague of mine has a funny sentence I really enjoyed. She's very smart. She said, the world has changed over the last 10 or 5 years from just in case training to just in time. And what does she mean by that? Just in case or just in time? Just in case training is, I'm going to go study Java for the next 40 or 100 hours. And don't talk to me until I'm done. But when I'm done, I'm going to be ready to write applications, just in case. Go study Java for 5 days. And she suggests the world has morphed. Nobody does that anymore. Who has 5 days? Nobody has 5 days. The world has become Google. How do I round up a floating point decimal number on Python using this platform? Everything is just get me over the next hurdle, just in time training. So how do you best learn Cassandra? There's the DataStax has its academy courses. There's courses on YouTube. There are people with blogs, certainly. And then probably shameless plug, only because you asked. So I write a monthly blog and I post it on GitHub. So it's on GitHub. And let me type this in real fast. If you go here, tinyurl.com/DDN is short for DataStax Developers Notebook. And then just for uniqueness, I called it 3000. That's a GitHub site, and it's a blog I post on DataStax. In the very first article in that list, maybe the second, should be a Cassandra primer. And then among those articles, there's all sorts of articles on how to use the document API, just the REST service endpoint. There's probably stuff, well, there's all sorts of stuff on running Cassandra on Kubernetes. It's not so much a Kubernetes primer. There's other ones out there. The expectation today is if you're a business, you're probably going to run even your database in Kubernetes. Hopefully that answered your question, but certainly Google, and there's a ton of stuff on GitHub or YouTube or other. What else, Ruben? Are you on mute?
We're almost, we have around 9 more minutes. Do you have any final thoughts that you want to bring to the community before we close the session?
No, I'm really glad to spend some time with you guys today. This was fun. And if your application needs meet that which is supplied by Cassandra, the always on, the linear scale, the Stargate, writing some of your application code or providing the functionality of some of your application code, and then specifically document API. If you didn't garner from the last 32 minutes, I'm a huge fan of doing less work than doing more work. And so shredding your JSON from your web and mobile app into rows and columns just seems to be the most senseless thing on the planet. Why am I writing all this code and having to maintain stuff that may break when I really am getting 20 phone calls a day to make the application do different application things? All that boilerplate functional code, that should just take care of itself. I don't even have to use, if you're screaming at the phone right now, go, well, use an object relational mapper. I don't even have to do that. Just leave it in JSON. It comes as JSON. I read JSON, I write JSON, end of discussion. And it's all automatically done for me. And then we saw the advantages of the indexes and. So that's my closing thought. Ruben, thank you. This has been fabulous. So I'll let you wrap it up.
Okay, thank you, Daniel, for your presentation, and thank you to all the attendees, the questions interacting during this session. You can contact the speaker directly if there is any further questions regarding this topic. Please provide your feedback using the form that we will provide in the chat box. Thank you again, everyone, for joining today's presentation, and I hope you gain some insight from this session. Have a wonderful day, and thank you for being part of this year's DataCon LA. Thank you, everyone, for participating, and have a nice day. Bye-bye.